All right, guys, I want to make a quick little video on this project submission, details, and submission. So I'm not really sure everyone's getting the project and ready to go on this project. So let me just give a little insight into the project. I'm going to look at this NHIS. So I'm going to go into the data and get to the NHIS data. So here's NHIS. So what I'm asking you to do on this project, I mean, I think, where is it? I don't know. Where's my, do I have? I mean, if you just, the project is the culmination of the semester's work. You are to creatively investigate and explore a data set and attempt to make new findings. This project is your opportunity to further develop your ability to work with real data and hopefully showcase your effort in learning in this class. Ultimately, I want you to dig into the data and put together a data-centric story. So really, this project is about you just demonstrating to me that you learned something this semester, that you can make contingency tables with 2 variables, with 3 variables. You can do an analysis of a numerical variable where you compare a numerical variable across 2 variables. You make overlay histograms. And then can you do inference? Can you then say, oh, I see differences here. Can I run a randomization test and make a conclusion that the differences are statistically discernible? Or if I see differences in the means, can I do a 2 means test and see what's going on there? Or if I got a big contingency table, can I do a chi-square test and see what's going on there? So there are like a lot of things I say, hey, do this, do this, do this, do this. Like there's all these expectations and there's these minimum expectations. But in all honesty, it is just about doing a good report. I think it starts right here with like 4 2-variable analyses. Try to do at least one with a numerical as your response. This might not be that easy, so if it doesn't happen, it doesn't happen. That's okay. I'm not going to be like, disheartened there. You should do some 3-variable analysis. Even though I say no inference is needed, you could do it. It is possible. It is possible, but you got to think about how to do it. And then, of course, I ask you for some 2-variable analysis. So let me give you an example. So here I am in the National Health Institute data. And say I just want to check out something. So I just want to learn something about this data here. Okay, so maybe, we've only looked at data from the Bay. So maybe I just want to do something simple. Like I'll just look at education. Is it true that women are better educated than men? Well, of course, this is going to be like kind of age dependent. So I probably would need to bin age to look at it, but I'll just make my life simple. I'll just look at one age group right now. So age is weird because it's close to 999. You'll notice there is some weird little things in the data, so you have to be careful of what's coming up in the data. But I'm just going to say, let's look at people that are between 30 and 39 years of age. Is there any kind of education disparity? So I'm creating a filtered data set. I got 30 to 39-year-olds. And I'm just going to make a very simple contingency table with sex as the row and education as the column and do row percent. So this is just doing a very simple analysis here. Now there's an unknown group here, but there's only like one person in the unknown group. So I don't like seeing that unknown group, so I'm just going to filter females and males and create filter data set and then regenerate this. So it's a little bit easier to look at, but there's also this unknown. So this unknown is we don't know what their education is, but it's kind of making a mess on my graph. So I'm going to get rid of that as well. The way I get rid of that is I just come over here to education and I select all of the levels except the unknown. So I'm just going through here. It's kind of funny. Is there no professional school or doctoral for 30 to 39-year-olds in our sample? I'm a little surprised that the highest is master's degree and nobody has the professional title. Okay, so I need to look into that. I'm kind of surprised that the professional is not showing up there. I think there might be an issue with the software. So there might be issues with the software. I mean, I hope there isn't, but I feel like there's maybe something wrong here where this professional or doctoral degree is not hitting. Anyway, I have this data now, right? A little hard to look at, a lot of different levels, but you can see master's degree, women are outnumbering the men. Bachelor's degree, it's men are a little bit higher than the women. Um, High school diploma, men are a little higher than women. Some college, pretty even. It looks pretty even. Like, I'm not sure this is really statistically significant. So one thing I can do with this is I can then download the data and I can run a chi-square test. So I can go into StatKey and I can go into here and do a chi-square test for association. I can upload the file and I can say, okay, let's look at education and sex and take a gander at this. So here's my sample. There's all my numbers. Chi-squared was 31.8. So shoot, actually there's quite a bit of association here. It's more of a story of the big sample size, my guess, because I don't really see big differences in the data. But what you would do here, so for if I was doing this one little slide, so let me just finish this up. So I'm going to do plot, bar chart. I'm going to do education here. I'm going to filter by sex here. I'm going to create myself a bar chart. I'm just going to show you like how the project might go. So I mean, actually, if you look at it, there is, definitely some little things going on. It's kind of funny. It's really just the top end and the middle end. And for some reason, I have to look into this, but I think the professional or doctoral degrees somehow got messed up when I was typing that in to here. But if we're going to make a slide, so I hope this isn't like too basic for you guys, but let me just show you what I would do here. So I'm going to go in here, make a slide, and here's my analysis. So this is like a sample. This is a pretty boring sample project, but I'm just trying to give you an insight into what the project's going to look like. So I might say I'm doing a two variable. Probably don't have to say two variable analysis. I'm just going to look at education versus sex for 30 to 39-year-olds. Okay. So first I would have my descriptive statistics. So it's okay. I'm going to take a picture of this right here. I'm going to take a picture of my bar chart. I'm missing a little details here, so I'm not really happy that I'm missing a little details here. Maybe I could blow this up and get a better picture of it. Sometimes I don't like it because it gets so small right here. What are we missing? Looks like we're not actually missing anything. It's all there. It just kind of looks like it's missing. So I'm not going to worry about that. I'm just going to take a picture of this. So I got education given sex. I'm going to put that in my slide. I'll save this for maybe something to do later. So we have my bar chart. And I'm going to come over here and I'm going to grab this here. Okay. So I don't really got anywhere to put anything, so I'm going to kind of make this a little bit smaller. And now I'm going to make my observations. So I don't know if I want to write a whole lot right here because I don't want to waste your time trying to listen to me think about how to write. But you would write up something right here like what you think about this, okay? And then on your next slide, you would say, I'm going to do a chi-squared randomization test. To see if there is an association. What I normally like to do here is I'd like to show the original data, because if you don't show your original data, I mean, of course we just saw it, but it's a good idea to have this original data here, because the chi-square test, it has the data here, but it's really awkward to look at. So I would just have this here, and then I would type in my number, 31.859. Okay, so I have pretty strong data here that what I'm seeing here is not likely to happen by chance. So I now have this randomization test right here, and still a little small. I would like to say something. Now I want to be able to talk about this as well. So when I talk about this, I definitely want to reference, my chi-squared value. Chi-squared is equal to 31.859, and then I'm going to write out, what that it is. There is association here. But right now we don't know how big the difference is. So if I look at this, it looks like, we come back to this, it looks like the differences are very, very small. It looks like what's driving this big difference is just the master's degree. So, I mean, maybe I'd want to show what's going on here. Where is the chi-squared the biggest? And you can see definitely that the chi-squared is the biggest with the master's degree. So it's probably a good idea when you do this kind of work to show where your chi-squared is coming from. I would think that would be something valuable to have. So I would get a chance to squeeze this in here as well so I could see where my chi-squared came from. And again, just trying to, a lot of it is you do have to kind of work on getting the format to look just right. Oh, this is for the wrong page. So I would put this in like right next to my chi-squared. A lot of times you can kind of almost, I find that I can just like put it right on the table itself. Okay. And then, so I'm going to follow up. So this is chi-squared randomization. This is for education versus sex. So I kind of keep this little story going. I know what everything's going on. This is also, I should remember that my filters. It's a good idea to show what your filters are. I probably should have taken a picture of the filters. Like as I'm here, it's kind of a really wide one to take a picture of, but I would probably try to take a picture of these filters here so I know what I got. It's kind of funny though, because the filter that I only really care about is the H. The rest of them is just to get rid of the nulls. So I would probably just put this one into my report here so people know that indeed I am looking at 30 to 39-year-olds. And again, like, it's kind of good just to always have this consistent so people are sure what, they know what you're talking about. I'm doing 30 to 39-year-olds. Now, there's a couple more things to do here, because I did get statistically discernible data here saying that there is an association. So I've concluded there is an association, but I actually want to now compare. I want to see how big is the difference. So this is a confidence interval, and this is what I'm going to look at is the proportion with a master's degree. So I'm going to highlight this little area right here of the graph. So I might come in here and say, okay, I'm interested in how big is this difference right here. So maybe I draw myself a little shape here and say, this is where the biggest difference is. I want to analyze how big that difference is. Okay, so I'm just doing a little bit of stylish things. So we're analyzing the difference in master's degree. So I have these numbers here, so I'm going to go into StatKey. I'm going to go bootstrap for difference of proportions. Theoretically, I probably should do a randomization test first, but I'm going to try to live without, just for simplicity here. So let's see. So we got 215. I'm going to put the women in first. 350 out of 2310. So 350 out of 2310. And our men are 215 out of 2055. Okay. So there's my difference, the 4.7% difference. Hopefully that's the same thing I'm seeing right here, 4.7. And I'm going to do a couple thousand samples, do a two-tail, and I can say that the difference is between 2.7 and 6.6. So by running that data, I actually can now tell how big the difference is. This is a little boring. I'm not loving this project right now. Maybe I can do another example later. But here, I just kind of wanted to show you, like, this is the kind of analysis you would do. You look at two variables. You show me, bar chart, contingency table. Then you say, okay, I'm going to run a randomization test. You could have just looked at this one level. That would have been fine as well. So instead of a chi-square test here, we could have just done a two proportion test between these two groups. That would have been fine. Maybe it would have been better. I didn't know exactly where I was going with this. So sometimes and you don't know what you're looking at, you might just want to try a chi-square test first to see what that looks like, and then later you can focus in on one level. All right, I think that's all. I don't want to do too much of a longer video. I just wanted to kind of show you like what I'm expecting. So this is one two variable analysis. Well, I guess let me show a three variable analysis. So I'm going to say, okay, this was interesting. Let me now see if I can do a three variable analysis. So for a three variable analysis, I'll look at the same thing. I'll do sex. I'll do education again. And then I'll just pick some other variable to play into the mix. Actually, I'm going to put sex down as my group by, and I'm going to add in another variable. These are not the most interesting variables. I'm sorry. How about Hispanic race? What does Hispanic race look like? Okay. Oh, I need some real percents. So it starts to get pretty dang complicated pretty fast now. Actually, I want to do it the other way. I'm going to go Hispanic race, and I want to do sex here. It's going to be pretty messy looking. It's a lot of tables. But I'm really looking at this master's degree number. I kind of want to compare it across different races and see if I'm seeing like the same difference between males and females. So, of course, some of my samples are pretty small. My American Indian is only 30 and 32. Other single and multiple race is 73. But we are seeing a much bigger difference there. So maybe I'm just going to look at these four groups just to make my life a little easier and yours. I'm just going to look at these three groups. So let me show you what I'm going to do here. I want to be able to get this to one page, so I'm just going to reload my page. So now I got a new slide here. I'm going to now look at, I'm going to do a three variable. So I'm going to look at education, race, and sex. And this is again just for 30 to 40. And I could have increased this age groups. Right now it's just 30 to 39-year-olds. And my focus is going to be proportion with master's degree. Okay, back to my data. So I should have a nice little graph here now. I got white, Asian, Hispanic. That's what I wanted to see. I'm still not where I want to be. Oh, look at now the professional is showing up. And earlier I saw no professional. Was I missing it? Was it there all the time and I just didn't see it? Maybe I am blind today. Are you serious? Let's see. Hold on. Did I totally miss it? Is it here? Not here. What? Okay, so obviously there was something weird with my software, and now that I have it in front of me, it's showing very different. This was the table I made. Numbers are not exactly the same. It's still saying 15.1 and 112. Now it's saying 112 for males. That's not what I put in here, was it? Okay, well this is something brand new to me. I don't like to show this to you guys, the errors behind this. But actually the difference does not change. It's still like 4.7, but somehow this 215 number has really changed. Isn't that right? 250. Oh no, it's still 215. Okay, 215 and 350. And is the number still 2055? No, the rows are a little higher now. Oh, are they a little higher? Yeah, they're a little higher. 2319. Alright, something a little strange happened. I have no idea. There it is. There it is. So somehow this was like missing and then it showed back up. Weird things do happen. I don't know what to say about it. But let's see. I wonder if when I loaded it into here, did it show up? Professional showed up. So I don't know. Something weird happened. I can try to look into it, see what's going on. Anyway, okay. So now I'm gonna grab. I'm gonna make this a little smaller again. It's really tough to see all this because I got so many levels here. So this is gonna happen. That's why we're not gonna focus on every single thing. But I'll take a screenshot of it nonetheless, just to have it here. This is a sample that I want to pay attention to. You will have to make decisions like this as you're working. So I'm going to put this as like a reference page in the back, just so I have it. But I'm probably not going to put this into my table because it's just like it's not very easy to look at here. So, but what I'm going to do is I'm going to create myself a so when I do a three variable analysis, I want to use Google Sheets, and I'll paste this again. Actually, I can make my life a lot easier. I can just go here, and I can just focus in on this master's column. So I'll do one quick one here, master's degree, and just grab this data here, put it over here. Yeah, it's probably too small to see, but let's see what we got here. Oh, and I don't know which levels is which. So we got the first group was white, then Hispanic, then black, then Asian. Okay. So I got white, Hispanic, black, and Asian. So I'm doing analysis here. So I have my white group, I have my Hispanic group, I have my black group, and I have my Asian group. And now I can talk about what percent has a master's degree. And what's the first row in here? So first row was female for each of these. Okay. So I got female, and male. Again, this is old school stuff. We've done this a long time ago, but females I had 17.2% versus 11.1%. We got 8% females versus 4% for men. Black individuals, we got 10.2 and 7.7. These are percentages. And then for my last group, which is my Asian group, it's at 27.9 and 26.3. Cool. So this is the American data. It's pretty interesting what's going on. Quite a racial difference going on here. I could probably break this down to just a single decimal. And then I can, like again, all we do is then just make a chart. And we can customize this, put in a series, put some data labels. We actually have a pretty nice little table to talk off of. Here's your like used to be like this. And this is the proportion of 30 to 39-year-olds with master's degree in the USA by race and sex. So we just done an analysis. We've done a three variable analysis. I'm going to take a picture of this. I'll put it over into my spreadsheet. And this is where I'm saying, like, you don't really need to do inference on this because this one's definitely a lot trickier to do inference because there's, what do you do inference on? There's so much going on here. But then you would have a conversation about what do you see here, Obviously, you see big differences across race. You see a gender gap that's maybe the largest absolute difference is right here at 6% for white women versus men. For Hispanic, it's only 4%, but it's actually a 50%. Women are twice as likely as men, 8 versus 4. And here you got the 2 percentage point difference. But in all groups, females are showing a higher level of master's degrees than men. And Asians are outperforming tremendously every other race in America by double digits. Women and men. And their racial gap is actually very, very small, only 2 percentage points. So a lot going on. This is what I'm saying is this is the start of a project, right? I started an analysis. I looked at two variables, education and sex. I then looked at chi-squared randomization for association. I wanted to see if this was an association. And probably before I would have actually done this three variable analysis, I probably would have went after this analysis and I would have just looked at race versus education to see what differences there were there. So let me, I'm kind of eating up the clock, but you can turn this off anytime. Let me do this again. So I'm going to go. Well, let me do a different example. I'll do one more example here, but I'm still going to look at this 30 to 39 group. I mean, and you might not need to do an age group like I'm doing. This is just where I decided to start with. Oh, come on. I destroyed that, huh? Reset my table. I can tell my computer is really laboring. 30 to 39. Let's do a different example. So let's look at, what do we got here? I'm going to do a variable that's a little more interesting. Oh, let's look at Great Depression, stroke. Where's this one? Alcohol use. Alcohol drinking status. Oh, okay, let's check it out. Let's look at something like this. Let's just do one more, so just to give you an example. So let's look at something. So let's look at alcohol drinking status. Just wondering, like, are men and women equally likely to drink? Oh, let me start with bar chart. I like to always start with the bar chart. I'm just exploring, seeing what I can find. So here's males and females. Not that different. So we got these NIUs. So this is one of the things you're going to find out that there's these NIUs that show up in the data. We want to get rid of them. So we're going to do current drinker. We're going to do former drinker and lifetime abstainer. Okay. Create filter data set and I'm going to generate. I'm also want to go in, remember, and fix sex. So it's just two sexes. So just male and female. And this is just about cleaning up my output. So I have cleaner output. So now we can see actually 13%, almost 14% of women lifetime abstainers. For males, it's only 7.7. Former drinkers, so these are people who drank and then quit, that's 12%, and for men, it's 9%. But actually, in America, it looks like 74% of women are current drinkers, one drink in the past year. I mean, it's not a lot. And for males, it's 82%. Looks like quite a bit of an association here. So I could run chi-square test, or I could do a two-proportion test, maybe just asking the question, how much more likely is a female than a male to have been a lifetime abstainer, had less than 12 drinks in their entire life? You could then look at this and say, well, let me check out race. Back the bars here and check this out. And now we do get a lot of races here. So sometimes American Indian. This is other single and multiple race. This is American Indian again. So there's kind of some weird ones. I mean, you're probably going to find your analysis is going to be easier if you just focus on Asian, Black, White, and Hispanic. So it's nothing against the other races. It's just what happens is if we look at this table and we actually look at race, Hispanic, and column is alcohol variable. Hope I'm not taking everyone's experiment or taking everyone's project away from them. Row percent. So I could look at this, and why I was saying this is there's these last three groups are only 30, 30, 70. And I don't really know what this group is. It's just a single and multiple race. So it's like races that aren't hitting these categories. And then you got American Indian And some people just do other as their race too, so we don't really know exactly what's all going on here. So I would probably choose my four biggest races in this sample to analyze. It'll make your analysis easier to look at. So you could just say, okay, I'm just going to focus on Asian, Black, Hispanic, and white. And if I recreated this, I have this table here. And like maybe my interest is on lifetime abstainers. Maybe that's what I'm finding most interesting. You know, what race is more likely to have lifetime abstainer? You see, it's like 27% of Asians have never had more than 12 drinks in their life for 30-year-olds. So pretty remarkable. That's almost over 25% of the sample. And white is at the least. White is down to only 6%. Black African American is at second at 15.9, and Hispanic is pretty close by. Now, what I might want to be interested in, what about how does sex play a role in this? So I might say, okay, let me look at sex now too. So now I have Hispanic males and females, white males and females, Black males and females, and Asian Black and white males and females. And now, like, a whole different story starts to emerge here. So this is what I'm hoping for. I'm just hoping you're doing what I'm doing. You're sitting down at your computer, you're making some tables. I mean, one, you got to be able to do the analysis. So I hope you have the skills to be able to do the analysis. If not, you're going to like learn how to do it because you're trying to get this project done. But this is pretty interesting data. White has a very little gap, right? Only about 2%. You know, if you look at Hispanic females, it's like women are twice as likely as men to not have ever drank in their life. For Black, it's actually the opposite, where males are more likely than the females to have been a lifetime abstainer. Now, maybe this difference is statistically discernible or not. Maybe not, because sample sizes are pretty small and the difference is only like 2%. So we wouldn't want to really say, we would actually say, we don't know if males and females, they look like they could have the same percentage, or males could slightly be more. We're probably not going to be able to discern that based on the sample size. And then for Asian, it's like really dramatically different. When Asians were at 27%, females jump up all the way to 37%, and males are down to 15%. So the male number is actually, puts it is the highest for now. It's like it's second highest. So I don't know. There's a lot to see, but when it comes back to it, is this is what I'm looking for stuff like this. I probably should have showed a little more for the other things, but I just wanted to give you a little bit of a taste of what to expect on the project and how to take care of some things. But more than anything, get some work done this week. Start to make some tables. Come into class, and don't be afraid to. I'm going to try to sit down with each person in the class, each one of you, and see where your project's going and see how I can help you. All right. Take care.